Hi students, myself Sheikh Afreen. In this semester, I am going to deal the subject DEMP. So what is the meaning of a DEMP means? D belongs to digital, E belongs to electronics, M belongs to micro, P belongs to processor. So simply we call as a DEMP is nothing but digital electronics and microprocessor. So actually the DEMP has a two subjects. So DE belongs to one subject and MP belongs to one subject. But in this semester, they are combining as two subjects equal to one subject for you. So digital electronics and microprocessor. Now coming to, we have a 5 units will be there. So in this 5 units, 3 units belongs to digital electronics we will able to learn, and the remaining 2 units belongs to microprocessor. So this is that DEMP. Now coming for you standard reference textbooks. For digital electronics, standard textbooks are R.P. Jain and Morris Mann. These two reference textbooks belongs to digital electronics, and that Senthil Kumar belongs to microprocessor. These are that standard textbooks for DEMP. So now coming to that, what is the meaning of DEMP and why should able to learn the digital electronics and microprocessor? So digital electronics that deals with the branch of electronics that deals with the digital codes, that codes in terms of a binary data. So either it will become a zeros and ones. So now coming to the microprocessor. So microprocessor we are designing with the help of that ICs, integrated circuits. So later we will see in depth of that digital electronics and microprocessor. So now let's see here we have a 5 units will be there. So first 3 units belongs to digital electronics and the remaining 2 units belongs to microprocessor. Now let's see that first unit, numbered systems and code conversion. Here we will able to learn the basics. So how many types of numbered systems are there? How we will able to convert one numbered system into that another numbered systems? And what is the meaning of a Boolean algebra? How we will able to represent a Boolean functions? So based on this Boolean expression, how we will able to reduce the Boolean expression by using a different methods are there. K-map method. So based on this basics concept, we will able to learn in that first unit, numbered systems and code conversions. Now go for the second unit. Second unit is a combinational circuits. So how to represent the combinational circuits? So in this combinational circuit, we have a different types of combinational circuits are there. Encoder, decoder, multiplexer, demultiplexer, adders and subtractors. All we will able to learn in that second unit. Then go for that third unit. So in the third unit, sequential circuits. So in the sequential circuit, what is the difference between a combinational circuit and sequential circuit? So individually we will able to represent the sequential circuit. In that sequential circuit, we will able to learn the latches and flip-flops. Different types of flip-flops are there. SR flip-flop, JK flip-flop, D flip-flop, T flip-flop and master slave flip-flops. All these are the flip-flops we will able to learn in the sequential codes, sequential circuits, and registers, counters, up and down counters, shift registers. All these are the comes under that third unit, sequential circuit. Basic concepts. If you are very well the basics, then we can easily understand the first unit, second unit and third unit. These 3 units belongs to one subject. That subject is a digital electronics. Now coming to the remaining 2 units belongs to microprocessor. So already I told you DEMP is nothing but 2 subjects combining in this semester as a one subject for you. So first 3 units belongs to digital electronics and the remaining 2 units belongs to microprocessor. Now coming to the fourth unit. So fourth unit is a microprocessor 1. So what is the meaning of a microprocessor? How to represent the architecture of microprocessor, flag registers, addressing modes. So all these are the some of the basic concept we will able to learn in that microprocessor 1. Then go for the fifth unit, microprocessor 2. So microprocessor 2 means we will able to learn here 8086 some simple programs will be there. So how to add that 8-bit addition, 16-bit addition, binary arithmetic operations, some logical operations, all we will able to see with a simple programs in the 5th unit. And the same way we will able to learn that some more microcontroller 8051 microcontroller basic concept we will learn in that 5th unit. These are your all 5 units belongs to DE and MP. First 3 units belongs to digital electronics and the remaining 2 units belongs to microprocessor. So now let's see that first unit contents. What are the contents are there in the first unit? So let's see the overall contents. Then we will able to enter the first unit. Now let's see that first unit syllabus content. So now coming to the first unit. So in the first unit we will able to learn that 3 parts will be there. So first part number systems and code conversion. Second part Boolean algebra. And third part K-map method. So now let's see here numbered systems and code conversions. So numbered system and code conversion, first you should able to learn the numbered systems. So already we know that the numbered systems are classified as different types are there. Decimal numbered system, binary numbered system, octal numbered system, hexadecimal numbered system. Here we will able to learn some basics points. So what is the radix of each number system? For example, decimal radix is a 10, binary 2, octal 8, hexadecimal number 16. So it starts from which point to which point, minimum point and maximum point. If you are very well the basic concept numbered systems, then we can easily solve that problems on number based conversions. So number based conversion, very important in an exam point of view. They may be given as a one numbered system. They are asking to convert into another number system. For example, they may be given as a decimal number. They are asking to find out as a binary. So how to convert a decimal to binary? So if you are very well number system different types concept, then we can easily solve that problems on number based conversions. So in an exam point of view, compulsory they may be asking as a 2 marks question or 10 marks question regarding on number based conversions. Very important number based conversions. So then go for binary arithmetics will be there. So binary arithmetics means how we will able to add the two numbers, how we will able to subtract two binary numbers. There are some concept. Then go for that complements. So we have a different types of complements are there. R's complement, R minus 1's complement. So next one, signed and unsigned binary numbers. So how to represent a signed number, unsigned number? So some problems they may be asking in signed and unsigned binary numbers. So then go for binary codes. So we have a different types of binary codes are there. Weighted code, non-weighted code, reflective code, alphanumeric code, error detecting, error correcting code. So in that how to represent each numbers, binary codes, BCD how we will able to represent, XS3 number, how to find out the gray code numbers, all we will able to observe on binary codes. Then go for the first unit, second part, Boolean algebra and logic gates. So Boolean algebra and logic gates, basics definitions, basics theorems and properties of Boolean algebra. So basics theorems and properties of Boolean algebra means we have a different types of theorems are there. Duality theorem, De Morgan's theorem. So if you are very well, they may be asking as a 2 marks question. So what is the duality theorem? What is the De Morgan's theorem? Like that. So if you are very well that theorems and properties, we can easily understand. So then go for that Boolean functions. So in that Boolean function, how we will able to represent a Boolean function? So in that Boolean function, we have a two types are there, SOP form and POS form. So SOP means sum of product, POS means product of sum. So how to represent each Boolean functions? So then go for that fourth one, canonical and standard form. So canonical and standard form means already we learned that SOP form and POS form. Now we want to write the standard SOP form. So the standard SOP form is also called as a min-term form. Standard POS form is also called as a max-term form. So then go for algebraic simplifications. So they may be very important algebraic simplification. They may be given as a one Boolean expression. They are asking to reduce that number of literals. So how we will able to reduce the number of literals? By applying the some basic theorems, some properties. Based on that, we will able to reduce as possible as number of literals. So these are the some problems they may be asking. Very important, 2 marks and 5 marks algebraic simplifications. Then go for logic gates. So we have a different types of gates are there. Basic gates and universal gates. Basic gates means it comes under the AND gate, OR gate, NOT gate. And universal gates are NAND gate, NOR gate. So here we will able to learn each gate logic symbol, their output expression. Based on that output expression, you should able to draw the truth table. If you are very well the logic gate expression, then easily understand for you remaining second unit and third unit. So in that logic gate, you should able to identify each logic gate symbol, their output expressions. Very important logic gates, because when we are entering into the second unit also, so if you are very well that logic gates, we can easily understand the second unit and third unit. So then go for that. In that first unit, third part, minimizations of Boolean functions. So why we are entering into the minimizations of Boolean functions means, so when we want to reduce any Boolean expression, so how we will able to reduce the Boolean expression? By applying the some theorems and laws. But it will become a very difficulty which law you should able to apply, which theorem you should able to apply. So that disadvantage can be overcome by using as a K-map method. So without any complicated, by drawing the one pictorial diagram, based on the diagram we should able to write the Boolean expressions. So that expression we should able to follows the corner map method. So it is also called as a K-map method. In that K-map method, we have a different types are there: don't care condition, prime and essential implicants. So this is your overall first unit syllabus. So you should able to learn a systematic way, then it will become easily understand. So first unit is a basic unit. So if you are very well the first unit, then we can easily understand the remaining second unit and third unit. Why? Because the first unit is a basic unit. Okay. So in the next class, we will able to see the number systems. So in the number system, we have a different types of number system. We will see in that remaining next class. Thank you.